Good evening. Good evening to all. This is Dr. Vasundhara, Associate Professor and HOD, Department of Mathematics, Stanley College of Engineering and Technology for Women, Hyderabad. It's my privilege to introduce Dr. Venkateswara Rao garu, also known as Venkat, is a biostatistician at BMS Hyderabad. He holds a PhD in statistics from the University of South Florida. He did his master's in mathematics from JNTU Hyderabad. He worked in US for 8 to 10 years as a coordinator for statistics courses in college level and school level. With a strong background in statistics, mathematical modeling, fuzzy logic, and neural networks. He also co-authored two books, including Introductory Statistics published by Macmillan Learning. Venkat garu began his teaching career in Hyderabad. He is more passionate about Telugu literature. Good evening, sir. It's my privilege to introduce Venkat garu. Please start the lecture, sir.
Sure. Thanks so much for the introduction, Vasundharaman. I'm sharing my screen right now. Can someone confirm
Yes,
if you are able to see my screen?
Yes, sir. It's visible, sir.
Okay. Thank you so much for the confirmation. So let me start my presentation with asking a question to the team. If you are able to reply it in the chat, wonderful. Otherwise, that's okay. So how many of you actually are using lights in all your rooms wherever you are? If you are like attending this session from your home or if you're attending this from your office. So do you have all your lights on? Is it only for one room where you're attending the session, or is it like on in all the rooms? I'm asking this question for a reason. So if you're not able to answer it, that's fine. Otherwise, please, okay. Yeah, please, Kumar, you have your hand raised. Can you please unmute yourself, Kumar, and answer if you have anything to say? Okay, maybe that was a false indication. So anyway, the question for you all was asked for the reason because we are all doing the sessions of climate change and plans for renewable energy. And are we also participating in doing this in the best way possible from our end? The reason is we will use the lights even though we are not in the particular location, even though if there is no need for that light in the particular room, and we will leave it open. And then we will now start talking about like, we should now think about like climate change. We have so many rains and we have this issue and that issue, and we have to focus on like, reducing this carbon footprint and or whatever you can say about it. So are we actually consciously taking care about doing what should be done from our end, and then think about like how can we do it for the global level or even at least like regional level impact on it. So my talk today will be on statistical insights on the climate change and then renewable energy for a sustainable future. So statistical insight is one key word which I want to focus in my presentation today, because with the change in the computation and the industry, we got so much of data, like so much of data, and we can have a good analysis out of it. And then we can also have some trend observed from the data and to see like what can happen or what was happening earlier and what can be done for the best future. So the numbers speak a little bit close to what is reality if we have good data, of course, and then we can plan for the future accordingly. So my background is both mathematics and statistics, as Dr. Vasundhara has mentioned, and I'm more nowadays into like applications part of it, mostly into statistical aspects, working with the numbers, running the data, doing the graphs, and getting some insights, potential insights from the numbers. So let's get into the presentation now. So what is climate change? I'm just going through the definitions. I know like it's been like already like 3 days with these kind of definitions, but let me do the like the kind of honors this way, trying to talk about like what is climate change once again. It's a long-term shift in weather patterns due to human activities, primarily because of greenhouse gas emissions. Greenhouse gas emissions are mostly from different sources. We'll talk about it in the next coming slides. And what is it we're looking for here is we are trying to do climate data analysis, which is very essential for understanding the long-term environmental changes, and also to get some kind of policies identified and then implemented accordingly. In this presentation, I'm exploring three key indicators. One is carbon dioxide levels, and one is temperature anomalies, and then one other is like sea rise due to this temperature and carbon dioxide anomalies. Using computational and also statistical tools, mostly with the graphs, not numbers or anything. We'll talk about like going through exploring the graphs and see how it makes sense reading the numbers. And what are the key drivers for this climate change are like fossil fuels, which mostly include coal, oil and gas, deforestation and getting more land use for that reason, and industrial and agricultural activities also. So these are the main key contributors for the climate change. And what will be the impact of it? Why it matters? Okay, climate is changing. What makes difference to me? I don't really care. That's not the case, because now we are all facing this right today also. Like, we have like severe temperatures during the summertime, and we have like extreme weathers, and also like nowadays it's all about cloud bursts, as I mentioned earlier. So why are these things happening which were not there earlier, which were not even discussed in the past? Think about like wildfires, in California or somewhere else. So these things were never in the news. So why are these things are happening? This is a reason for that. Like the climate change is the reason for that. And one of the reasons for that, I can say. And then that is the impact we will have because of the climate change, and can also have a threat towards the biodiversity, food security, and also human health. So that one most important factor we need to keep in mind is like human health that is impacted a lot due to extreme weathers, and also due to like floods. You can also look into that, like, and different cases. What is the urgency for this topic? What we are trying to cover from the last few days is this is the very important thing. The global temperatures are now having some increment close to like 1.2 degrees Celsius on an average. And that is above the pre-industrial levels, which was defined by NOAA, and which is not a good move. So we want to make sure like how can we get it down, and how can we not get it more than 1.5, which is the cutoff by Paris Agreement. So we'll also talk about it. And without any action taken, this warming, what we are seeing right now as approximately 1.2 degrees Celsius, could exceed even 3 degrees by 2100. So you might say like, I'm not going to be there to see this 2100 year at all in my life, but think about the future generation of yours. So they might be having this impact because of the things what we do today. So how can we make these things kind of in control, and then we can have a good future for the generations? So that's the actual plan we have to do based on the numbers and based on the situations what we are facing right now. So the goal for this presentation is, as I mentioned, we want to see like, what is the impact, and then how are we going to see the changes in the numbers using the graphs and analyze the data. And also we will showcase the sustainable energy solutions to mitigate these effects. And maybe we can think about some few proposals for policymakers, or even for us, and also for the communities to take into account so that we can achieve our goals. So greenhouse effect, GHS, greenhouse gases, we call them as, and these contribute a lot for the climate. And the gases like carbon dioxide, methane, and nitrous oxide, they are actually the key gases which trap the temperature and which trap the heat in the atmosphere. And we have to control that. We should not have excess. We should not have like minimal. So it should be in control. That is how we can actually have our temperatures in control. And it's a natural process to have a green gas effect, but now it is now amplified because of human errors, or I can say like human related emissions more and more. So think about this. What is this greenhouse effect is? Like, suppose we are actually covering ourselves under one blanket for some kind of a cold weather that is keeping you warm. Now think about like having like, 10 of such blankets on you. Will you be able to breathe? That is the situation we are now trying to address. Like one blanket is natural greenhouse effect, and 10 blankets is like the gases which are more than the excess, which are like now being emitted, which is causing the trouble. So among these three gases, carbon dioxide is contributing 76% of global emissions, and methane is contributing 16%, and nitrous oxide is contributing about 6%. And due to this, in 2023, we have an average carbon dioxide of 419 ppm, methane of 1922, and nitrous oxide of 336 ppb, which is the highest record. Make a note, this is the highest record from the past many years. These numbers were never been touched. So now we are going in incremental order, like we are trying to go for exponential change, which should be now cut down, and we should not face any issues due to that. So carbon dioxide, how is this actually produced? Like, how are the sources for that? The main source for them is like coal, oil, and natural gas. These are the main forces. And then deforestation, of course, followed by cement, manufacturing, and decomposition of organic material. And this contributes heavily for warming for many reasons. And one of the reasons is prevalence. It will stay for long, the carbon dioxide, and it will stay in the atmosphere for for ages. So that is one of the reasons. We have to make sure we will keep it in lower levels so that it won't be causing any trouble. The next contributor is methane, and methane sources are from the fossil fuel, and fossil fuels and livestock digestions, and agriculture also in one way. And we have to think about like waste treatment also. Like as we can see, like we have nowadays talking about like waste management systems. So we have to also think about like how do we keep these things in control and in a kind of a contained way so that it won't emit any methane. Methane is one of the very high trapping heat than carbon dioxide, and it will be like for shorter time, but it will keep the temperatures very high. The life of it is approximately 10 to 12 years in the atmosphere, but still, if you keep on generating methane thoroughly, it will never be gone. It will be there for ages again. And the next one is the nitrous oxide here. And for nitrous oxide, the key source of the emission will be like agricultural, mainly synthetic fertilizers and manures. So nowadays, we also are thinking about like, don't use synthetic fertilizers, try to use like, organic, don't use any fertilizers if possible. And there are like pros and cons about it, but that can actually cut down the nitrous oxide. Though the percentage of nitrous oxide is very less contribution, but it is like lasting for long, approximately like over 100 years, it will last in atmosphere, and it will also contribute for very high warming potentials. And the 3 points what you see here, the carbon dioxide, despite being less potent per molecule, dominates overall warming due to its sheer volume and long persistence. Sheer volume, remember, it's 76% contributing to this climate. And methane, it's a powerful punch over the short term, and it rises the levels like more immediately, and then you can see the warming very immediately too. Nitrous oxide, even it is like less prevalent, it will be retaining the powerful warming impact over the long time because of staying in the atmosphere for like more than 100 years. And it is often overlooked than compared to like methane and carbon dioxide. People say like, oh, it's a very less percentage, but think about like slowly if it contributes more and more, and if you're not taking any precautionary measures, eventually at some time it will be like one of the key factors for the temperatures and the warming increments. And what are the key sources of emissions for our carbon dioxide or and any other gases? Major sources, as I mentioned, include coal, oil, and gas, which will be like 40% of the contribution. Transportation, industry, agriculture, and deforestation, there are 2 digits contributions. And industry is, of course, like second majority, like 19% of it. Transportation goes to 16%, and the deforestation and agriculture. And fossil fuels account approximately 90% of the carbon dioxide emissions globally. So these are all things which are contributing 90% of carbon dioxide, which you are actually facing in the climate for 90% of it. Excuse me. And carbon dioxide levels have risen dramatically after the industrial revolution. More industries, more carbon dioxide. They are like directly proportional. And then the pre-industrial baseline, it was around like 1900 or 1850 to 1900 era. They have like approximately the baseline is 280. That was the cutoff the industry has defined. But now currently, and 2024, the recorded value is like little more than 420 ppm. You can see like it's getting closer to even like double the pre-baseline. And major contributions are fossil fuels and deforestation. And what are the trends what we can see in this case? Global temperatures, as you also are facing every day, are showing a consistent upward trend. Like as year by year, we will never see anything which is like, the temperatures during the summertime is very less. It's like, oh my God, this is more hot than like, previous year, summer times. And these anomalies are calculated relative to a baseline. So we have a global baseline defined for the calculation of anomalies, like how is the temperature and the trend. And the baseline was calculated based on 1951 to 1980 data, where the temperatures were like comparatively like steady and there are not like so many ups and downs in the data. And there is a strong correlation, it is understood, between the greenhouse gas emissions and the temperatures, what you see in the global trend. And the historical data which we are talking about, like 1850 to 1900, which has like very stable temperatures, so we don't really feel any change. And in 2024, the anomaly what we have faced is addition of 1.2 degrees to the temperature, which is like close to our cutoff of 1.5 that should not be exceeding. And some regions also have seen exceeding addition of 2% in the degrees of Celsius. And on average, it's like for the 2024, it's 1.5. We have a kind of anomaly, the temperature increase globally. And with projections, what we can see is if you do not take any action at this point, this warming can reach to 2.5 to 4.8 degrees more by 2100. And the Paris Agreement has a target where we have we call it as Paris Climate Agreement or something. It has a target. They say like it should limit to 1.5 degrees Celsius and try to keep it that way. Or if it is required, don't go beyond 2. It should be below 2. And good is keep it below 1.5 or up to 1.5. So that is the agreement, so that we will not have any climate related issues even for next century. So let's look into now some sort of graphs, like, how is the temperature on like, surface temperature uh, above pre-industrial defined times. So if you can see these graphs here, this graph is talking about 1970 approximately to 2004. And the cutoff, what you see here as like plus 1.5 on the y-axis, is the cutoff of the climate agreement in Paris. And you can clearly see 2024 is the first year where we can see we are crossing the pre-industrial level of 1.5. So we are crossing 1.5 here. And combined with 2023 and 2024, the average is 1.54 as per the numbers. It's 1.54 degrees temperature more than the pre-industrial level. And as I mentioned earlier, I repeat, the Paris Agreement is aiming towards this. Like we will hold the increase in the global average temperature well below 2 degrees Celsius, above predefined industrial levels, and making sure the temperature will not increase by 1.5 degrees Celsius above again pre-industrial level. So the maximum cutoff they have made is 2, but we want to have not even reaching 2. We will cut down before 2 itself, 1.5. That's the best way to do. And one time or two times, if in an average, if you see like average crossing 1.5, it does not mean that, oh, now we are breaching the Paris Agreement, so what should we do now? No, once or twice we can have up and down in the calculations, but if you see a consistent increase of cutting down 1.5 or up, then that's something where you have to consider about this is a breach as per the Paris Agreement. We need to think about like what can be done. So that is the graph talking about like how will be the information, like how is the graph changing, the data for the surface temperatures changing year by year. Going to the next slide here, what are the disruptions we have? Like, what are the reasons for this kind of changes, what we are noticing lately? First, we will see like, in the recent years, Earth's natural carbon sinks include forests and soils. They absorbed significantly very less carbon dioxide due to extreme droughts and wildfires. And when they do not absorb the required carbon dioxide from the atmosphere, what will be the situation is carbon dioxide will remain with us. So that could be the reason we are seeing this situation. Instead of them acting as carbon absorbers, now we have made them as carbon sources for ourselves. So this is hindering the photosynthesis process. And that is the reason why we can see like, okay, earlier it was like the trees absorbing the carbon dioxide from us, but there are no trees anymore because deforestation happened. And now what is this carbon dioxide doing? It's with us around. And that is the reason the carbon is increasing, and that is actually giving us the warm temperatures. And what is the current state? As I mentioned earlier, we have like around reported 420 ppm of carbon dioxide in 2024. more than what is the predefined industrial 280 ppm. And this also impacted oceans. So due to this carbon dioxide in this part, what is actually in the air, which is not absorbed properly by forests and soils, this is now absorbed by like oceans, and that causes so much of acidification in the oceans, which is not even good for ecosystem in the oceans, and even for any resource for any resource for research also. So this is the back stab for our own selves for not taking care of forests or taking care of soils. But it is not late, never late. We can also plan accordingly. So feedback loops are other things. So we can also notice sometimes in the news that the Arctic ice is like kind of by thawing by itself, and it is also causing accelerating due to the warming what is noticed around. So this thawing, like getting into like a liquid state, whatever of the ice what we have, is increased over 30%, and it is even close to 40%. And this is also added because of the wildfires which are being identified. So these things will also cause the kind of ocean and sea rise also due to this kind of melting of Arctic side. And that's the thing, the consequences. The warming accelerates soil respiration, leading to increased release of carbon dioxide from the soils. And this warmer oceans will hold less carbon dioxide and absorb this kind of process because of this. And this will be like in this process, in the air for us. And we are actually facing the weather or climate changes due to these facts. What are the global emissions of carbon dioxide? As we know, like global energy related carbon dioxide increased by 1.51% in 2023, which is approximately like 410 million tons, to reach a new high record of 37.4 billion tons. Like that's the high record noticed because of the carbon dioxide emissions. And this compares with the increase of 490 million tons in 2022, which was like 1.3% earlier due to the coal. And emissions in China grew around like 565 million tons. I will also show you the graphs about China and other countries also. In 2023, China has emissions around like 565 million tons, by far the largest increase globally. However, there is a other side of China too. China is also continuously investing in for clean energy additions, and China is dominating in that compared to the other countries. So though there is like so much of carbon emissions from China, it is also taking severe steps to make sure they invest more on clean energy also. And in India, strong GDP growth drove up the emissions, and it also emitted like 190 million tons. But due to weak monsoons, we have an increased demand of electricity and cut down on the hydro production, and this is now increasing our emissions in 2023 for a little bit higher comparatively. So weak monsoons, like because of like no rains in time or like heavy rains in time, these both are also sometimes causing some trouble like this. So comparing to the 2024 data, global emissions, as I mentioned, is like approximately 37.4 billion metric tons, and the annual growth globally is recorded as approximately 1% for 2023 from 2023. And top emitters, the three major contributors for these emissions are China, United States, and India. They are contributing approximately 50% of the actual emissions around the globe. So how will be the trend? Like if you want to see like the bar chart of these emissions from different years for these major contributing countries, how does it look like? Let's have a glance at it. This graph talks about like how much of the metric ton, million tons of carbon dioxide emitted for the years 2021 to 2023. And we have considered top 5 countries which are contributing to this carbon dioxide emission. And you can see among all these, the top country is China. And year by year, the emissions are actually increasing. That is very unfortunate. And year by year, you can see it's increasing. By 2023, it actually has like 12,000 metric carbon released also. And the next to that is United States. After China, the leading second position is for the United States. But the good thing is United States is seemingly consistent. There's no increase. It should be decreasing for a positive way, but we don't really see any decrease. But glad that we don't even see any increase like we see in the Chinese climate data. And the next followed by United States, the third position we have is India. India also has a slight increase from 2021 to 2023, but it is like negligible when compared to the change what you see in the China emissions. So the other two countries which are contributing are like Russia and Japan. They are like contributing less comparatively to the other three countries. So the carbon dioxide emissions from combustions in advanced economies, I am trying to say is like, developed nations. We can think about it like that. So from the developed nations, what is the like carbon dioxide emissions from combustions from 1973 to 2023? The graph is pretty much interesting to notice. What you see here is from 1973, this dotted line is the carbon dioxide emissions as the cutoff. We have considered as 1973 cutoff. From 1973, the data seems to be going low and then going up and then going low. And from 2000 and up, it is going very high. And later on, as you can see by 2023, it has crossed this cutoff of 1973. And it also fell below 1973 because 1973 value was here around 10.5 or something. And it is actually now reduced to that even that level. So these high advanced economic countries are investing more into sustainable energies, and that is the reason why you can see a drastic fall eventually from like 2000 until like 2023 and 24 and so on. So this can be achieved, but developing nations sometimes they need some support to achieve these things. Developed nations, they have that kind of funds to do these things and then see these changes happening in their nation. And what are the changes? What we have combustion by sectors? Like, there are several sectors contributing. So many sectors contributing to the carbon dioxide emissions. What is the change from 2022 to 2023 from different countries? So you can see this graph where, for example, the contributors for carbon dioxide are power sector is contributing, transport is contributing, industry is contributing, and buildings are contributing for the carbon dioxide emissions. And these colors you can see below, like which countries are contributing more. Like China is contributing for more in the power sector, followed by India, and then so on and so forth. And good thing what you can also see is these advanced countries or developed countries, they have a downfall, like they have a decrease in their calculation of carbon dioxide emissions. But globally, this is not much different. If you take all in an average, the carbon dioxide emissions are still not that kind of less when you are considering power sector. But among all these, the interesting thing to notice is the transportation is contributing more. That's the first ranker in this carbon dioxide emissions, carbon emissions in these sectors, which the transport globally is high. And it's contributing approximately, if I'm not wrong, 240 million tons globally. And that should be controlled. And there are several ways of controlling it, but implementation has become very tough. Like, for example, in the United States, they have offered some kind of initiatives and incentives where if you share the ride to your workplace, you'll be given some kind of, reimbursement or something like that. So rather than like 4 people going in 4 different cars to their workplace from the similar location or same location or nearby locations, you would rather share a same ride so that it will contribute less to the emissions. So some sort of these incentives must be given so that we can have this carbon emissions can be in control for the transport. And when you see among all these, the interesting fact is about buildings. So buildings in 2022 and 2023 globally also is contributing less carbon imprint, and also for the developing countries. And even other countries are also like, I can say like minimally or even zero contribution to the carbon. So when this was able to be achieved, everything else can also be achieved. The only thing is a proper planning can be taken into account, and we can usually get into this kind of reduction in the carbon footprint. This is only for 2022 and 2023 data. I couldn't find any further data for that. And by sector, we already seen this one. This is in the other graph, but particularly for 2024, what was the contributions for the 2024? You can see that electricity and heat is contributing high for the 41% for the carbon emissions, followed by transport, which is 22, and the industry with the 20%, and rest of them are like buildings and forestry, which is like approximately 8 and 9 and 8% respectively. So major is electricity and transport and industry. These three are high. So we are talking about energy, and we are talking about electricity, and we are talking about temperature increase and everything. Now, what is the reason for that? is the reason because of the consumption increase also? Is the energy consumption increased accordingly, and that is the reason why we have the carbon increase? The reality is true. That is correct. And you can see that the energy for the 2024 has a 2% increase from 2023. And in the same line, the electricity demand has increased by 4% because of electrification and cooling needs. Everyone needs like the cooling needs because of the high temperatures. So that increases the electricity demand also. It's like again in a correlation format. And in the same way, fossil fuel is still dominating. 80% of the global energy mix is now because of the fossil fuel, among which coal is taking 40%, oil is taking 31%, and gas is taking 22%. And how is the energy, like global primary consumption of energy we have? As you can clearly see, coal is taking high consumption, followed by the oil and then the natural gas. The good energy, which is like renewable energy, is in a very minimal count. Like for you can see like solar, wind, hydropower, and nuclear, they're like negligible. And we are now trying to focus on these things must be taking the major role, and then we should cut down on the remaining coal and oil so that we will be having such less carbon emissions in the world. So what is this now? We are talking about renewable energy. Renewable energy can be hydro or wind, or it can be solar, or it can be like bioenergy. They can be anything. And you can also see that they are growing rapidly. But the thing is, they are only contributing a small share. That should actually grow rapid and also contribute more to reduce the carbon imprint. So approximately 8% of renewable energy has its imprint on like 2023 analysis, and within that also hydropower and bio is actually like dominating as per 2023 statistics. I recall it's at 2023, but yeah, hydropower was dominating in there. And in the past few years, as I said, we can see that renewable energy is in the discussions, and but still its participation levels are very minimal, and it only has 45% share in the global electricity as per 2024 analysis given by report IRENA 2025. And solar and wind capacities have seen an increment, 24% and 13% respectively. We have solar and wind capacities increased as per 2024 statistics. And the impact, we have to focus on this one. Okay, there was a study conducted in 138 countries for the data of 1995 till 2021. The study wanted to see like, is renewable energy useful in the reduction of carbon? The answer is yes. The renewable adoption has reduced the carbon emissions in 90% of these countries. So this is now an established fact with numbers and research. Now the only thing is, now we need to focus more on getting funds and implementing these renewable adoptions, and then we can see this same in the rest of the nations also. So how much is the share we have between the renewable and fossil fuels? The share you can see in this graph. You can see the yellow part in the bottom of the graph is the is the renewable, and then the gray part on the top is the fossil fuels. The renewable energy from 2010 to 2024, you can see there is a good change in the increase of renewable energy, but that took so much time. But with this understanding of the usefulness of the renewable energy and the research being conducted, we can anticipate in the next 5 years, we can see this growth getting 40 to 80 and 80 to 100 very faster, because now we have strong evidence that the renewable energy is contributing less to the carbon into the atmosphere. So this can help us to focus more on funds into renewable energy. So we will now try to understand about like the numbers, where how much is the energy consumed globally and also in major portions like Asia Pacific and Americas and also Europe region. So regional analysis, we want to do that. So global energy consumption increased. This is like a little bit high increase of 2.2% in 2024, faster than its historical 2020, 2010 and 2019 trend. So the historical trend was like between 2010 to 2019. It was identified as the faster increase, which is like at least 1.5% per year. Now in 2024, it has crossed that and reached to 2.2. And especially for the BRICS nation, we have seen 3% increase in the global consumption. And this could be because of temperatures and looking for more of cooling atmospheres. So that could be the reason why. So which accounted for the 43% of the global energy consumption and posted a strong economic growth. This in China, it was earlier like 4% and averaged to 7% in 2023. And India, it has increased to 5%, which is more than what is noticed in 2010 to 2019. And Indonesia has increased to 6%, which is more than the historic rate for Indonesia. So it's twice than that. So these changes are happening because of more consumption, and more consumption is happening because of the more requirement of the climate situations and having to have a cooling situations in and around. Energy consumption grew at a slower rate in OECD countries. OECD countries, because they have taken, OECD countries are like developed countries in other way. So it can be anticipated, that can be noticed as will be slower, approximately 1% on an average. And the trends are also interesting. In the United States, it's 1%. And in South Korea, it has 2% increase. In Australia, again, it's 1% increase. In Turkey, it's 6%, a little bit more compared to the rest of the countries. And whereas it remains stable in European Union, Mexico, and Canada, and in Japan, it reduced by 1%. So these are things which we can see because of their approach to renewable energy has reduced the energy consumption directly from these things. Going further into region wise, I'm now talking about Asia Pacific, and then what are the emissions and what are the renewable energy related actions they have taken. So the emissions, this region of the planet is responsible for about 60% of the global greenhouse gas emissions, and 62% of global fossil fuel related carbon emissions. And this is already discussed earlier in different slides. And this is mainly because of industrial developments, transportation increments, and then deforestation of getting land use, more land use situations. And very few wildfires in this part of Asia Pacific nations, but that is also one areas or one reasons for emissions of carbon in this way. So the other major contributing to the carbon in Asia Pacific countries is we are also still heavily dependent on coal. Coal is one of the major electricity producers for us in China and also in India. So that was one of the reasons which is also producing more carbon emissions. And what are the steps they have taken? We are also taking very good investments in, like, how can we have renewable energy and how can we cut down on the emissions of carbon. So in 2022, 345 billion US dollars have been deployed to make sure, like, we will cut down on this kind of carbon emissions, and then we are trying to use it in the best way possible. This is about Asia Pacific. And then in Asia also, we can see China and India, they are accounting for approximately 80% of the energy demand in 2024. And India has notably, we have seen in the previous slide, has grown to like 5%, and China is under like 3% of this energy requirement. However, China still remains the largest emitter of emitter of carbon, and also the leader for renewable energy also. As I mentioned in the previous slide, coal is the key energy or key for us in both China and India. And for in India, what is the other major of course, coal is dependency for the electricity, as mentioned. The other thing is like urbanization. Like we are now like having more of like urbanization happening in India, and that is causing more kind of carbon emissions also. So that cannot be stopped because of the population growth, and that should be taken in a kind of a very different way, so that we can also have like less carbon footprint also. So as I mentioned, like China and India are like more using coal, and that is for electricity, and that is causing more reason for carbon emissions. And for Americas, as I mentioned, they are mostly using like clean energy from nuclear, wind and solar, mostly nuclear, which are using 42% of the electricity. And coal share is less in America, which is like well below 15%. And that is the reason we don't have much of carbon emissions. And fossil fuels still produce 58% of the power, even though we are using nuclear of 42%. The remaining 58% is like, from a fossil fuel. That's not bad, but in 58%, most of them from the gas, constituting 43% of it. And US remains like a significant methane emitter also. Like compared to other nations, other countries, US is the country which is highly emitting like methane from its side. And what are the decisions they have taken is they have already like spent so much on renewable energies for now, nuclear. However, they don't really have much towards what you call like solar or wind, the reasons being due to the cost and also permission issues. For solar and wind, they need to take so many permissions from so many places, and those permissions are not granted easily in that country. So that is the reason they don't really have that much of that. They're only mostly towards like nuclear and portion of renewable energies. And coal, of course, as I mentioned, is declining, and clean energy is going to like approximately 40%. It will increase in future years also. And US again is the second contributing carbon emitter, and it has good policies, and the policies have been changing as the rulers are changing, the parties are changing. So that shifts are impacting so much on the carbon emissions also. So the policies what they have are not stable. They're changing as the party change. So that is causing that kind of trend in the trajectory. And for the Latin America, where they have like good sources of water, the hydropower is of course dominating. 50% of the electricity in the country of Brazil is from hydro. And still there is a problem with the deforestation. There is like 11% of Amazon forests been cut down since 2000. This should be also discussed in very international platform to make sure deforestation should be minimized in every country. But the urbanization is creating this problem. We have to find some other way for that. In Europe, Europe is kind of very good with its approach. It is reaching towards the climate target as planned. We don't have much emissions from the European Union countries. The 55% cut down to greenhouse gases by 2030, it can be achieved. So we are good with that, on track with the climate targets. And we can see deep decline in emissions also because they have their policies. I can show about the policies in the future slides. They have policies on what they say as a carbon tax. If you emit more tax, more carbon, you have to pay more taxes for that. So that kind of things made European countries to decide on like what to do next, and they have gone to the renewable energy. So that's how they cut down on the carbon. So this is the leader in renewable adoption, and we have to take this as our inspiration in other countries also. 60% of electricity from renewables in 2024. That's a very good number. And carbon pricing, as I mentioned just now, that is actually is the reason why the reduced emissions from 2005 we have like 35% reduced emissions because of pricing the carbon. You have more emissions in your area or in your industry, you need to pay more for that. And there is also a challenging situation in the European countries where there are some geopolitical tensions going on. So it is trying to figure it out to fix those tensions and then implement their renewable policies so that they can get to the 2035 target. So by the forecasting, we are talking about like from 2023 to 2030, we are trying to forecast on how will be our situation of electricity generation. So if you are actually going on renewable electricity, as you can see in the line graph, if you implement this aggressive approach of, to reach 65%, that's like aggressive approach, of course, emissions first should drop from 43% to 26% by 2030. So if we can drop the emissions, which are like currently like 43% as in 2019, if we can drop them by 2030 as to 26%, then we can have like renewable energy also. We can see this path as like an increasing high. And as you go for longer terms, we can also plan to have like zero carbon emissions by 2050. So as I mentioned, this is like an aggressive approach. The policies must be very strict, and that must be also practiced, not just decide on the policies and not implementing it cannot get to that position. But strict policies can also have some backlash. People might not be like people, and also industries and also parties might not be kind of so pleased, but we have to figure it out. Countries have to have their own policies for that. So what are the impacts of these rising temperatures? Okay, now temperatures are rising. What is the impact now? You can feel the impact right now sitting at your house. We have like kind of rains and like floods even in cities. That's like very kind of the reason we can see, like, this is because of rising temperatures. And 2024, congratulations to all of us, is the hottest year on record, surpassing 2023. 2023 was hottest as per the records, but now 2024 actually has surpassed 2023 to get the award as the hottest year. And also the heat waves increased by 30% since 1980. So heat waves, as you can also face it when you walk in sun during summertime, the heat waves will really literally kill you. Like, you cannot like walk for 10 minutes in the mid day of in the summer season. So that is because of these rising temperatures. And not only that, we have regional effects. Like, for the Arctic region, the warming has increased by twice the global rate. And then the tropical region, we can also see like several increased cyclone effects, and then that is because of increased temperatures. The graph with the base of pre-industrial levels, you can see the graph in the temperature anomaly, like how is that increasing from 1940. Then what is the pre-industrial level we have is like 1850 to 1900. That's the pre-industrial level where the temperatures were like not so much. You can see the trend going up in a very rapid way, in an exponential way in statistical terms. As you can see, like in 2024, it's touching 1.5, which was also discussed earlier. So this is not a good path for any country. So we have to cut down this, and then we have to have them have a decline at least after this year or something like that. So what can be done? We have to discuss on it. So not just the temperatures, due to this we also will be facing sea level rises, like melting glaciers and polar ice rise the sea levels, and that can give a threat to the coastal cities and islands, especially with floods and erosions. So if you think like how is the temperature impacting the sea level, is you can see like the coastal cities are like now flooded away if there is anything. And even if there is like an island, if there is an increase in the sea level, eventually that island will never be there. So we'll never see that. So the data, what we can see from 1993 to 2023, the mean sea level globally is increasing like 3.7 millimeters per year. That's like not a smaller number. As you can see, like approximately 10 centimeters of increase in the sea level since 1990. So you may see like 10 centimeters maybe like is like this much, but think about it globally. If it is going this much, it will occupy the land, and it will actually take away the small islands completely forever. And then there will be like super flooding in coastal areas, and then we can also have risking 100 million peoples by 2050 if nothing precautionary measures are taken for this increase in the temperatures or climate changes. So you can see the sea level rise from 1993 to 2023. It's like literally going like globally high. Line graph is literally like straight with the slope this high. And there is a small change from 2018 to 2023, but it's not that great. So the sea level in millimeters, you can see like is very high globally with graph. And we can also talk about like extreme weather events. Extreme weather events like, we can see like heat waves, droughts, floods, and storms because of this increase in the temperatures. And also wildfires are becoming very common. Wildfires are common and even larger and given more destructions. So you must have also read the news in different countries. These things are happening a lot. This is only because of increase in the temperatures. And these are like extreme weather events, floods, storms, like wildfires. We never even discussed this like no like 10 years back. Now they're like super in the discussion. And the frequency and the severity of extreme weather events increased from the few decades. And according to NOAA, the number of billion-dollar weather disasters in the US has tripled since 1980s. That is like too much. Like number of billion-dollar weather disasters. Like in the US, one of the major disastrous thing is hurricanes. We'll talk about it in the next slides also. If there is an hurricane, and if it is like a 5 scale hurricane or like level 4 hurricane, you can imagine that like that area where it hits, it will be completely like wiped away. So that will be causing so much of a loss in billions for them. And also statistical analysis shows a positive correlation between these global temperatures and then the frequency of extreme events. So there is, of course, a very good strong correlation. So we are not having this because of no reason. These are happening because of increase in the temperatures and because of increase in the carbon. And the trends, what you can see in the extreme weather events, as I mentioned, hurricanes, 10% increase in the intensity since 1970. And I was kind of a victim for like two hurricanes when I was in the US. I mean, I didn't really had any loss, but we had to face so much of like, that kind of hurricane related emergencies and sirens and everything. That is not fun. Believe me, that is not fun. And we have to think about it. And droughts, and it affected like 2.5 billion people since 2000 to 2020. And then wildfires, it's now 2 times more compared to 1990s to 2020s. And this is costing a lot. It is costing a lot, approximately $200 billion annually on an average. This is the economic cost because of these extreme weather events. And these are the numbers which is trying to tell you like what are the heat events and droughts, extreme events. In if this trend continues without any precautionary measures, you can see the heat waves could be like approximately 4 times more than the frequent ones. Droughts can be like more than 2 times, and then rainstorms can be approximately 1.5 times more. So we can cut it down if we can take some precautionary measures. If not, it can reach, if it is 1.5 degrees consistently as this year, you can see this kind of increase in the heat waves and everything. And this graph tells you literally like how much of flood storms and extreme temperatures have caused the damage since 1930 until 2023. So the numbers are like, you can see like exponentially increasing. 2019 has reported approximately 1,500 events of like, storms and floods and others. So these curves, what you see are like floods, storms, extreme temperatures, droughts. These are the things which are contributing. And this dramatic growth, like, when you see like in 1930s, it's approximately 11 or something like that. And then by 2000, it's like 500. So this is only because of the increase in the temperatures. Now, what is the discussion? Like, what is the topic of interest we are trying to cover is climate change. And these are the results. Yes, the climate change is giving you this kind of drastic growths, and we have to address that. So this also can cause biodiversity loss because of these temperatures. Though we can see like there will be a disruption in the ecosystem, like there will be extinction, as I mentioned earlier in one of my slides, 1 million species are about to extinct, which is like not good. And we are also seeing some kind of coral reefs bleaching, and mostly towards like Pacific Ocean and somewhere towards the US side. This is because of like extreme temperatures. And then there is also a shift in biodiversity and migration patterns. So like the shifts in the sense like how are the things which are supposed to be in their actual places shifting to some place which are not their actual house, like the species in particular. And then the data also clearly says like 1 million species are at risk. And then we have like almost like 50% of wetlands destroyed since 1900. And this is not like a smaller number. So we'll also have like losses in glacier and ice. Like, for example, like the mass loss happened in the glacier is 20% since 1980, which is like very high in very less time. And Arctic Sea has like seen 12% decline per decade. It's not like overall 12% decline per decade since 1979. So Arctic Sea ice is like having that kind of loss in its ice quantity since 1979. That's a decline. And what is this impacting towards? This is impacting towards like water supply disruption for like approximately 2 billion people. And of course, accelerated sea level rise, which we have discussed, like approximately 10 centimeters increase in the last 10 years. And the Arctic Sea melt, you can see the extent can be seen clearly from 1979 until 2024. How much was the decline, which is like apparently very high, which is unfortunate. That should be discussed. This line chart shows you how is the decline of ice um per decade. Socioeconomic impacts. How is this impacting the temperatures? How is this impacting in the socio-economic ways? Economic losses, of course, will be there because of damage in infrastructure. As I mentioned earlier, hurricane damages so much of infrastructure and houses and agricultural fields and also livelihoods. So this should be a loss, and that is economic loss. And also it will increase the insurance cost. Like as you can see, if there is a disaster and if you are in a disaster prone area, the insurance for your house will be very high. and that high impact of that, and if there is a kind of raise, that will increase accordingly. So this will be a burden for everyone. And immediately you can see about like the climate disasters. 1.5 trillion damages have been reported for 14 years of period throughout the world. $1.5 trillion. It's like, oh my God, kind of amount, which can be reduced maybe if you plan accordingly from today. And crop actually has dropped its yield by like around approximately 10 to 20%. And if this continues, it will be by 2050, you'll not have crop yields at all. It will like drastically reduced by 20%. And 30 million migrants are because of climate changes reported in 2023. And if no precautionary measures are taken, you can see approximately 200 million will be migrating from place to place by 2050. And now health. How is this impacting health for anyone? There is a very good risk towards health, and we have to be very careful. Like when there are so much of rains, we are now seeing kind of flu, or now they are also calling it as maybe the symptoms of COVID. That is only because non-planned such rains or non-timely rains. And this is increased, like the health risks increased, heat related illnesses, excuse me, and deaths. And also it spreads malaria and dengue in new regions. It was only limited to few regions where they were like impacted. Now because of this temperature changes, malaria and dengue are being reported in new regions also, where there was no reports earlier in the last decade. So that's one of the major health risks or which have been identified. And the direct effects, what can be noticed from the data is heat-related illnesses were reported like approximately 5 million cases annually, and vector-borne diseases such as malaria and dengue are spreading to the new regions. And indirect effects are air pollution. 7 million premature deaths are happening because of air pollution and because of the carbon and because of the increase in the temperatures. And this is the report from WHO 2024 data. 7 million premature deaths. And food insecurity. 500 million undernourished by 2030 if this is the same trend which you follow. Undernourished is like no healthy food possible for anyone, like 500 people, 500 million people will not get healthy food at all. And reduced crop yields from heat and drought, and water scarcity due to declining snowpacks and dry rivers. So these are all the things which can be seen, which are already in the trend. And if no precautionary measures are taken, it will be like in an exponential way. So what can be done? We are now done with like, this can happen, this can happen, this can happen. Now, what can be done so that this will not happen or this can be minimized? And what can it matters? Sustainable energy. Sustainable energy refers to a kind of renewable energy, clean energy, or environmentally responsible energy, like such as solar, wind, hydropower, thermal, geothermal, etc. And we need to be very careful and invest on it. And then we want to have that carbon imprint or footprint reduction. So we'll go one by one. When we have this sustainable energy, it can fight with climate change. How does it fight? It fight by cutting down the greenhouse gas emissions. So greenhouse gas emissions are contributing very high to the climate, and this can be cut down if we opt towards sustainable energy. So sustainable energy, as I said, includes like anything which is like solar, hydro, or anything. So if you can cut down on oil, gas, coal, the first primary thing is coal, and then this will cut down the emissions of carbon, and that will cut down the greenhouse gas emissions, and then we will have better life. It will help in protecting public health. Because of high climate and carbon emissions, there are so much of toxic pollutants, and that is the reason like premature deaths also. So if you want to cut down that, we want to have sustainable energy which will have its impact, like protecting the public health. Because when you use less fossil fuel, and then there will be less air pollution, and then there will be more clean air and clean air energy resources, and which will significantly increase the health for the public. So we can think about it by doing sustainable energy path. And then which also like, increases energy security. This is very important. Energy security is something we must be addressing. It will not have anything from the outsourcing. We can have the renewable energy which can be locally sourced. locally sourced, and we will be having less dependency from the imported fuels. So if we have less dependency on the fuels, we can have a locally sourced energy, which will have a very good security for our own energy levels. So we can have sustainable energy in our own local resources. And the other one is it will drive for jobs. You may think about like how jobs, the data, statistical data, published data, I don't recall which journal, but the data says that 13 million people are employed, which are in clean energy resources, and they clean energy resources, something like that. I forgot about it. So it will create green jobs, and industries will provide these jobs for you. 13 million people 13 million people in 2023 have reported this jobs because of this green energy initiative. And it will also ensures the access and equity. Like, you can have affordable and clean energy for all.